Hello everyone, welcome to Lab 8. This lab will build upon what we learned in Lab 7. If you have not watched those, please do so because there will be information in those two videos that I will not be repeating in this lab. In today's lab, we are going to a different operating mode called CFC. This operating mode is for asynchronous motors, and it's a mode we recommend using when it's an option to get the most dynamics out of your motor. For the motor to operate well, it needs to be tuned. So we will demonstrate tuning the parameters for this operating mode and evaluating the motor's performance using the scope software. In the previous labs, we have shown the VF and VFC operating modes. VF and VFC are voltage control modes, and when we switched to VFC, we were able to increase the motor's performance by using the encoder and tuning the parameters. Today, we are going to further increase the motor's performance and switch to CFC mode. CFC stands for current flux control. This means that instead of controlling the voltage to adjust the motor's magnetic field, like VF and VFC modes do, this mode will control the current in the motor to adjust the magnetic fields. Current control results in very dynamic operation, where it can respond much quicker than voltage-controlled modes. This mode can get asynchronous motors to have dynamics that are more like permanent magnet servo motors. We learned in the previous labs that the VF mode doesn't use the encoder, and the VFC mode can be used with or without an encoder. Well, CFC mode needs encoder feedback with the encoder attached to the motor's rotor. The encoder provides the position and speed of the rotor shaft for the controller to calculate how it should apply the current. Also, this mode is only for SEW motors. The controller has to know the exact characteristics of the motor to be able to calculate the motor model and control the current. It's not possible to calculate the motor model of non-SEW motors, so the CFC mode is only an option when there is an SEW motor and that motor has an encoder. The CFC mode also only works for one motor with one MOVIDRIVE, so it can't be used in applications that have multiple motors connected to one MOVIDRIVE. Lastly, the tuning process that we will go through for the CFC mode will be the same as the servo mode. So if you have a permanent magnet motor and need to tune it for the servo mode, you can apply what you learn here for that scenario. When you go to tune the motor's performance, it's very possible that the motor could make scary noises and jerking motions if extreme values are loaded to the tuning parameters. You will need quick access to an e-stop or power disconnection method to quickly shut down the MOVIDRIVE if the motor's behavior is erratic and uncontrolled. Let's head into the Motion Studio software and get started with changing our operating mode. Now we're back in the Motion Studio software, and the first thing we want to do before starting our lab is to back up the parameters from the previous lab. So I'm going to select the MOVIDRIVE and then drag it from the bottom and then drop it to the top. It's going to ask if I want to reuse the same name, and I'm fine with that. And I'm going to click on Finish. The progress bar is done moving, and we have blue colors on both sides, so we're done uploading, and we can click on OK. And then now we have a backup of the previous lab parameters in our offline project. So now let's go ahead and factory reset this MOVIDRIVE. So I'm going to right-click on it, go to Startup, and then Parameter Tree. I'm going to go to Folder 8, Unit Functions, Item 80, Setup, and then Parameter 802, Factory Setting. I'm going to change it from No to Delivery State. It takes a second to process, and then the MOVIDRIVE will reboot here shortly. Okay, the MOVIDRIVE is rebooted again, so let's go ahead and close out of this. And then let's rescan our Ethernet network. And it's going to tell me that the name has changed and it's got different properties, and that's okay. So I'm going to say, yes, I want to update the network. The first thing we want to do now that we're starting from scratch is to name our MOVIDRIVE for this lab. So I'm going to right click on it and then come to Properties. And then we're going to call this MOVIDRIVE MDXB and then CFC for the operating mode that we will be starting up in this lab. Click on OK. Now the name has changed. Now the next thing that I need to do that I didn't show in the last lab is I am communicating over Ethernet. And when you delivery state the parameters, your Ethernet settings will change as you do that. And this could present a problem when you go to turn the power off to the MOVIDRIVE and then turn it back on, that when you try to rescan back into the MOVIDRIVE, it doesn't allow you to rescan into it. So I'm going to right click on the MOVIDRIVE, go to Startup, and then Parameter Tree Online. I'm going to go to the Ethernet parameters, which is in folder 7, Control Functions. And then item 78 is the Ethernet configuration. And then it does not change your IP address or your subnet mask, but what happens when you delivery state the parameters is parameter 785, the DHCP startup configuration changes back to DHCP if you previously had it set to saved IP parameters. So if you use a fixed IP address and you do not have a DHCP server assigning your address to your MOVIDRIVE, then make sure if you delivery state the parameters that you come in here and then change this DHCP back to saved IP parameters. So that way, if you power cycle your MOVIDRIVE, you can rescan into it without any issues. The other way to fix this is if you can't scan into your MOVIDRIVE over Ethernet, you can change this parameter with your keypad, or if you have a USB serial cable, you can plug into the MOVIDRIVE with a serial cable and then change this parameter over the software using serial instead of Ethernet. So I'm going to click on Saved IP Parameters and make that parameter change. And now it's changed in MOVIDRIVE. So I can close this and then close the parameters. Now let's go into the motor startup and change the operating mode for this MOVIDRIVE to CFC. So I'm going to right click on the MOVIDRIVE, go to Startup, Startup Online. And then this currently has no startup in it, so that's why the controller optimization is grayed out, because I have not loaded any motor parameters to this MOVIDRIVE yet. So I'm going to click on Perform Startup. I'm verifying that I'm starting up parameter set 1 because we're not using parameter set 2, and then I will click on Startup Set 1. I do want to do the complete startup, and so I'm going to click on Next. We are going to be in the vector controlled mode, and then click Next. This motor does not have an encoder that provides nameplate data, and that's perfectly fine. So I'm going to click Next. The motor that we're using is a DR motor, so I will select SCW motor, DR. And then now I'll look at a picture of the motor nameplate and then set up the motor type. This is a DRN80M4, 60 Hertz and 0.75 kilowatts. Here it is right here, DRN80M4, 60 Hertz and 0.75 kilowatts. The motor rated voltage is 460 volts at 60 Hertz. The mains rated voltage is 480. And the encoder type is an AS7W, so I will look through the list and find W, and here it is right here. It's the only option that has W at the end, so I know that's the one for the AS7W encoder. And then there is a temperature sensor on this motor, the TH, but it is not connected to the MOVIDRIVE, so I'm just going to leave that to no sensor since it's not connected. Now I'll click on Next. Yes, I do want to use the encoder because we're going to a CFC mode that requires it. Click on Next. Speed control is fine, and then click on Next. And then in the previous lab, we had chose VFC control. So in this lab, we want to go to CFC control. So I'm going to click on Current Mode Flux Control. We are not using a size 7 MOVIDRIVE or any of these conditions here, so I'm going to not check that box and leave it unchecked. Click on Next. And this is the screen to tune the CFC mode. So what we're going to do to start off with is just load some generic values, and then we will test that to see how it performs, and then come back into the screen and actually do the tuning. So you do need to go all the way through the startup first, and then tune after you've already loaded the startup one time. It's not possible for me to tune right now because I have not yet loaded the motor parameters to the MOVIDRIVE. So I'm just going to use the same stiffness and load inertia from the previous lab. So the stiffness in the previous lab was 1, and the load inertia in the previous lab was 75. The drive will be without backlash because this currently is not connected to a gearbox or any type of sprocket and chain system that would possibly have backlash. It's just an output shaft with a flywheel on it. So I'm going to leave this to without backlash. If your application did have backlash in the gearing, then you would want to make sure that you choose with backlash because that does affect the overall tuning performance of the motor. But I'm going to leave this to without backlash. It does have a brake, so I'm going to change this to with brake. It does not have a Z-fan, so I'm going to leave it to without. And the shortest required ramp, we're going to put that to 1 second. The external control time reference, I just click here and it will load 1 millisecond automatically. I don't recall a time where I have needed to modify this from the default value, so you can just leave that to 0 or 1 millisecond if you click in the box. Here is the inertia for the motor, and there are no slave axes that are following this MOVIDRIVE. It is just one motor and one MOVIDRIVE, so we're going to leave the number of slave axes to 0. And then now I will click on Next. I will apply these proposed values for the current limit, the torque limit, and the speed monitoring settings, and then click Next. Here are the tuning parameters based on what we've loaded so far, and I'm just going to click Apply Proposal for now, and then we'll come back in and see if we need to modify these any from the load, inertia, and the stiffness that we currently have set. And then now click on Next. And then here are our ramp time proposals and then our speed limit proposals. So I'm going to apply those and then click on Next. Now I will click on Finish to download these parameters to the MOVIDRIVE. And then click on OK. Now let's go into the scope software, set up our scope recording, and then test run this MOVIDRIVE with the stiffness and the load inertia that we used in the last lab and see if just by changing the operating mode, if we have gotten better performance out of our motor using some values from the previous lab. So I will right click on the MOVIDRIVE, go to Diagnostics, and then Scope Online. I will open up the recorder settings, choose Empty Record, click OK. The scope is currently running on the MOVIDRIVE, so I'm going to have to press Cancel to change any of these settings. And then just like the previous lab, I'm going to use the measurement values of actual speed, set point speed, and the output current instead of the active current. And then I'm not concerned with the binary inputs, so I'm just going to turn this to no data. The sample time, we'll use the same one from the previous lab, and that is a sample time of 5 milliseconds. Then we can use the pre-trigger percentage from the previous lab, which was 5%, so I'll type in 5 and then press Enter. In the previous lab, we used the brake release signal to be our trigger source to start the recording. I'm not going to use that this time, so that way we can demonstrate a different trigger method. So I'm just going to leave the trigger source to manual. And that means the only time that this will trigger is if you physically press the button. So now what I want to set up for a different trigger event is I want to use this analog trigger. It's currently grayed out and I can't change anything here, and that's because it's not connected to this trigger mode box. So to get the connection for analog trigger to the trigger mode box, I just click on analog, and it will draw a line between these 2 points, and now it gives me a selection to select the analog trigger. If I didn't want the analog trigger, then I could just press the box one more time, and then it disconnects the line, and then this is no longer selectable. So I'm just going to click this again to get it to show up, and then I want to trigger this recording on the actual speed. So there are some parameters here that you can choose as different analog triggers, but I'm going to leave it to the actual speed. And I want to set up this analog trigger to start the recording if I cross a certain speed value, either in the clockwise or the counterclockwise direction. So if I leave the operator to equals, that will only work for the RPM value that I set in one direction. So if I need to trigger in either direction of rotation, I need to change my operator. So I'm going to click on this button for the operator. And then now we have a different one that's less than or greater than, so min and max value. If I click it again, we can see there's only a less than operator, greater than operator, a rising edge operator, a falling edge operator, and then we're back to the equal sign operator. So I want to be the less than or greater than operator. So I'm going to click this one more time. And the minimum speed will be my counterclockwise direction of rotation. So I will type in negative 300 because in the counterclockwise direction, the speed is shown as negative. And then in the clockwise direction, I will use a speed of positive 300. So this analog trigger will now trigger this recording regardless of how I start this motor, either in the clockwise or the counterclockwise direction. And then I will leave this error connected to the trigger, and it will trigger if any fault happens. Now, if I didn't want the error to influence my trigger event, then I can just click the error box and disconnect it. That could be helpful if you are troubleshooting a scenario and you're getting some fault codes like a field bus timeout that aren't that interesting, and you don't want that to mess up the possible recording for something else. So you can disconnect your error so that way the trigger of the scope does not happen if any fault happens on the MOVIDRIVE. But since we're tuning, it's very possible that we could create an error on the MOVIDRIVE. So I'm going to reconnect this error box and then leave it for any fault that happens. Okay, now these settings are done being configured. Let's go ahead and send these settings to the MOVIDRIVE. So I'm going to click on the Start button. Now the scope is running on the MOVIDRIVE. Let's go ahead and close this. And then we can just pull our scope window down. And then I need to make some changes to the parameters of the MOVIDRIVE so that way we can run it in the same scenarios like we did in the previous lab. So I'm going to go back into the parameter setting and then right click on the MOVIDRIVE, go to Startup, and then Parameter Tree. And then I need to make the change to the set point speed and then also the modulation frequency like we did in the last lab. So to change the modulation frequency, that's going to be in folder 8, Unit Functions, item 86, Modulation. And for the previous modes, we have been modifying parameter 860, the PWM frequency number 1 for parameter set 1, and then we have been activating the PWM fix for parameter set 1. Well, these PWM frequencies are only for VF or VFC operating modes, not for CFC. So if I want to change the PWM frequency for the CFC operating mode, I have to use parameter 864 PWM frequency CFC. And then now I will change this from 4 kilohertz to 16 kilohertz, so it's quieter for the training environment. And then these fixes do not work for parameter 864, so I can leave the PWM fix off. Now we can close the modulation, and let's set our set point speed. So that's going to be in folder 1, set points and ramp generators, item 16, fixed set points for parameter set 1, and then we're going to use set point N11, and we're going to change this to 1000 RPM, and then press enter, just like the last lab. Now we can close this and minimize this, and let's reopen our scope tool. Now the scope is open, so we can go ahead and maximize this again. So the scope is running and the trigger has not happened yet. So let's go ahead and run our motor. So I'm going to clear the inhibit on the MOVIDRIVE. I'm going to activate the set point speed, and then I will activate the enable. And then as soon as I activate one of these directions of rotation, the motor will start moving. So I'm going to start with the counterclockwise direction of rotation, so that way we can test our trigger event and make sure that it triggers in the negative speed direction. So I'm going to go ahead and activate this, and then flip the direction of rotation, and then flip it again, and flip it again, and flip it one more time, and now we can stop it. Now let's go ahead and load this recording and see if the measurement values look anything like the previous lab exercise. So I will press this load button. Okay, and to make this easier to view, I'm going to change the background color to white again. So I'm going to go to Extras, Settings, Colors, and then change the scheme to be white, and then click on OK. Then Auto Scale Sorted is currently selected, so let's go ahead and uncheck that, and then auto scale the recording for the measurement values on the screen. It's going to bring them all together in the center, and so now let's organize the waveforms by clicking the curve offset, and then pulling them in the directions that I want them to go. And we can see that just by changing the operating mode and using the same stiffness and load inertia from the previous lab, that this recording actually looks really good. But let's go ahead and zoom into these overshoot pieces right here and get a fine look at what the overshoot is doing. So let's go ahead and click the horizontal zoom in the X direction, and then let's zoom into this piece right here. Let's double click to get our cursors, and let's compare this piece of the overshoot to the set point. So I'm going to pull the set point into that area and make sure the set point shows 1000 RPM, and it does. So let's now grab cursor number 1 and then go right above it onto the actual speed. Now we have everything aligned, and we can see that the overshoot of the actual speed, which is the blue line, versus the set point speed is only 4.8 RPM. So that's a very big improvement from the VFC operating mode, which we had gotten the overshoot to be around 10 RPM versus the set point. So this is quite a bit of improvement from just changing the operating mode to CFC. So let's zoom back out by pressing the minus magnifying glass. And then let's look at our recording and see if there is anything else that could be improved with our tuning. We can see here at the beginning of the recording that this solid vertical line is the trigger event, and that it triggered as the motor was accelerating in the negative or the counterclockwise direction. Let's evaluate this piece and see if it was around 300 RPM. So I'm going to zoom into the X direction for this. And then let's get our cursors here. And let's just pull cursor number 1 to this point and see what the speed was at. We can see the actual speed was at negative 309 RPM when the trigger event happened. So we can see with just using the analog speed trigger event that it still works for different scenarios. So definitely play with your different types of trigger events, because it can improve how you are able to capture your measurements automatically with the scope tool. So let's go ahead and zoom back out. And let's evaluate these current peaks and see if they're maybe too high. So I will grab the cursors onto this magenta line, and then let's get into one of these pieces right here where it looks like it spikes pretty high. So let's zoom into that and see what that peak is at. Okay, and then cursor number 1, it's saying that the output current was at 37.69%. That's actually not that high because the MOVIDRIVE is allowed to go to 150%, but this is the output current of the MOVIDRIVE, not of the motor. So you would have to calculate, is 37% of my MOVIDRIVE, what does that compare to the actual motor current rating? It's possible that you can have a MOVIDRIVE that's 2 or 3 times the current of the motor. So say, for instance, you had a MOVIDRIVE that can support 30 amps, but the motor is only rated for 10 amps, then your MOVIDRIVE would be 3 times the current of your motor. So you would need to calculate your output current percentage and make sure that you are not sending too much current to your motor, since this percentage is of the MOVIDRIVE rating, not of the motor rating. All right, let's zoom back out. Now the tuning right here looks really good, but let's go ahead and just go back into our startup parameters and see if we can maybe improve it further. Maybe we can get these current peaks to be a little bit less, or maybe we can get these overshoots to be a little smoother, but we won't know until we try. So let's go ahead and go back into the startup parameters and then show how to tune the CFC operating mode. So I'm going to pull down the scope window and then go back into the startup. So I will right click on the MOVIDRIVE, go to startup, and then startup online. I can jump straight into the controller optimization now because we've already loaded the motor data. And it opens up our CFC tuning. So one thing that's going to be different than the VFC mode is you will have this testing button here. Now this testing button is going to be available in the CFC operating mode and in the servo operating mode. So what you see here will be the same for CFC or for servo operating modes. But if you click on this testing button, it's going to give you some information about how you should run your application and then what this testing button does. And essentially what it's saying is that you need to run your application in the most dynamic way that it would normally be running, and then have this testing button active so that way you can try to determine the load inertia that's reflected to the motor shaft. So for this training, we only have a flywheel on this motor, so the only way for it to be able to detect the inertia is to try to go forward and reverse. So we're going to run this motor forward and reverse repetitively for several seconds or several minutes, depending on the application. And if the load inertia can be calculated by the MOVIDRIVE, then it will populate the load inertia into this value automatically. So we can click on this OK button. And then now we will have a black box that surrounds the testing button, letting you know that the testing is currently active. So what our goal is to get the load inertia value to populate and settle to a measured value. So we'll go forward and reverse. And this could take seconds or it could take minutes. It really just depends on the inertia of the system. Okay, we can go ahead and stop it there because it's only changing on the 10th decimal place now. It's not changing at the whole numbers anymore. Now we have a load inertia that is measured at 16.7, down from 75. So let's go ahead and click on next and see what the proposed values are. We can see that our previous values was a gain of 3.5 and the time constant was 11, and it has not changed on the time constant. It is adjusting some of the acceleration gain and then the filter values for those. And then it's also adjusting some of the gain for the positioning and the hold controller. If you're new to tuning the motor's performance, you may not be comfortable adjusting these parameters manually, and that's okay. Let me just explain what each of these parameters are so that way you can go through your tuning process, and when you see these values change, you can have a general understanding of what changes are being applied when you press this Apply Proposal button. Parameter 200 is the gain of the speed controller, and this is how hard the controller will correct for differences between the set point and the actual speed. A lower value here means that the controller applies less correction, and a higher value here means that it applies more correction. If you have an application that is stiff, then this P gain value may be set too high. If the application is loose, then this P gain value may be set too low. Parameter 201 is the time constant for the speed controller. This is a time value in milliseconds of how often the controller will check the actual speed for accuracy. Lower values mean that the controller is checking very frequently, and higher values here mean that the controller is checking less frequently. If the application is stiff or if there are oscillations when running a constant speed, then this value may be set too low. If the application is loose and not holding the set point speed well, then this value may be set too high. Parameter 202 and further down to parameter 203 are the gain and the filter time only for the acceleration portion. So if you are needing to adjust the performance of the motor during acceleration or deceleration, then you would need to look at adjusting parameter 202 and 203. Parameter 204 is the filter applied to the feedback signal of the encoder, and often this is fine being kept at the proposed value. Parameter 115 is the filter for the analog input set point. This is only used when the MOVIDRIVE has an analog input as a set point. Parameter 210 is the P gain of the hold controller. This is only used when the MOVIDRIVE has its hold control function active to keep the motor in position without a brake. This value represents how much gain is applied when the motor is at standstill. Parameter 910 is the gain of the positioning controller. So if the MOVIDRIVE is doing any type of positioning moves, then this gain is a value of how hard the motor travels to the set point position. If the value of the gain X is high, then the motor may over travel when decelerating into the set point position. If the value of the gain X is low, then the motor may decelerate too soon and then have to slowly arrive into the set point position. You will only need to adjust this if the MOVIDRIVE is used in a positioning application. Another point to note about this gain X parameter is specifically for applications where there is an external encoder connected to the MOVIDRIVE for positioning. For example, when there is a laser distance encoder or a barcode encoder used, this gain is very sensitive with those types of encoders. Oftentimes, the gain has to be set manually at or below a value of 0.1. That seems like an extremely low value, but if the gain is set too high, then the application may have harsh jerking or vibration during the positioning moves. So specifically for external encoder applications, you will need to manually check this value and set it to a value of 0.1 and then adjust from there according to how the motor performs. All right, I'm going to go ahead and press the apply button to accept these proposed values. Then I will click next, and then I will just click on download. Now let's go back to our scope window and then run this motor and see if that has improved any from the previous recording that we conducted. Okay, the scope is now open, and let's make this bigger. And then let's go ahead and just restart our recording with the same settings that we previously used. And then we'll leave this previous recording on the screen. And we still only have 10 seconds before that recording is finished. So I'm going to run this forward and reverse for 10 seconds. Okay, let's go ahead and load this recording. Now let's change the background color. And then let's make it bigger so we can evaluate it. And then first, let's just check our current peaks and see what those are at. So I will now zoom in the X direction. Double click to get my cursors there. Now we can see our current peak is only at 33%. So we were able to get a reduction in the output current of 4%. Let's go ahead and zoom back out. And then let's check some of these other peaks. 32%. And then this big one at the very front, let's see what it is. 37%. Okay. Now let's minimize this one. And then go back to the previous recording and then evaluate it again. And then let's check this current peak at the very beginning of it. And it's 38%, so that's the same, that's unchanged. But this peak right here in the middle of the recording is 37%, and we were able to get it down to 33%. So that is an improvement there. And then let's look at our speed comparison between these two recordings. The new recording is at the top, and the original recording is on the bottom. It's a little hard to see the speed variances here, so let's go ahead and modify our resolution for each one of these recordings. So I will select the recording I want to modify, and then I will come to this vertical box over here. And then the actual speed, let's change the resolution on that one to be 200. It's going to take it a little bit off screen, so let's go ahead and use the curve offset to bring the top of the recording back into view. And then let's go to our set point speed and make it 200 as well. And then let's pull it back into view. And then now let's minimize this one, and let's go to the second recording. I'm double clicking on that to open it. And then let's modify the resolution for it to be 200. And then for the set point speed to be 200. And then we will use the offset to pull it into screen. And let's minimize that. And then now we can see those a little bit better, and then we can zoom into it as well. So I'll just zoom into that piece and then zoom into this piece. And then I can use this scroll data button here, and then I can actually pull this over to better align it. Okay, and then now we can look and see that the new recording on the top and the original recording on the bottom, that there is a difference to the speed adjustment. It's very small, but it is an improvement. So let's use our cursors and see the difference between these peaks right here. So let's double click because I don't see the second cursor. Let's get the second cursor right here, and then the first cursor right here. And we can see the difference between those are 19 RPM down here at the bottom. So that's 1004 RPM versus 985 RPM. And it gives me the difference. Let's compare it to the top recording. Double click. Let's go to this value at the top, and then let's go to this bottom lower value here. And the difference between those is 1005 RPM versus 1001. So a difference of 3.4 RPM right here at the beginning. So there is quite a bit of improvement between the original recording and this new recording. Okay, and if we zoom back out and then zoom back out on the new one, we can see that just by changing our operating mode and then modifying the load inertia, that we were able to get a lot better performance out of this motor. Now, in a real-world scenario, you would probably need to keep tuning further and further to better hone in on some values that work well for your application. But looking at this recording, I would say this is very good tuning, and I would leave it alone if I was able to get a measurement like this out of an actual application. So let's go ahead and just close this first recording because it's no longer needed, and we know that that's the tuning that we don't want to use. So we can close that one, and then I'm going to say, no, I do not want to save it. But I do want to save this new recording, so I'm going to go to File, and then Save As, and I'm going to name it to Scope, CFC, Stiffness of 1, and then a Load Inertia of 16. And then click Save. Then I will put some comments here just as an example. So I'll just say Example, Comments, and then show you how to view those if you open up the recording. So now I will click on OK. It's saved that on my desktop, so I can pull this out of the way and then pull the Motion Studio software out of the way and then look at this scope here on my desktop. I will open it directly, change the language back to English. Now, if you want to view the comments that you entered in a scope recording, once you open up that recording, you can just click on File and then Properties, and then you will see your comments right here in the File Properties box. You can type in your tuning settings here for each recording, so that way you can compare them later if you need to. The way I've shown it is just by entering in your tuning settings as the file name, but it is possible for the file name to change and those to get lost. Then you can put them here in the comments, and they should stay with the scope file even if the scope file name changes. So we're just going to click on Cancel because we're done viewing those. And then now we can close this scope window. And let's make Motion Studio bigger again. And then let's head back into the startup parameters. Now, the demo we're using in this lab does not have a lot of inertia because it only has a flywheel, and we were not able to simulate the load of an actual application. So that made it very easy to tune. But your application may present a scenario that is a little more challenging to tune, and you may find yourself needing to manually adjust some of the tuning parameters. Then you can just come back into these startup parameters, press the back button, and then make your manual adjustments to this download value column. Just make sure after you type in a new value that you do not press the Apply Proposal button, because it will overwrite what you just typed in with the values that are over here on the left. Then when you get done with your manual adjustments, you can just press the next button and then press Download if you want to go back in the future, or Finish to download and close the window. We're happy with the tuning parameters that are currently in the MOVIDRIVE, so we're just going to press the Cancel button. Now, let me show you where these parameters are located in our parameter tree. So I'm going to head to the parameter tree tab that is already open. And then some of the tuning parameters are in folder 2, so that's controller parameters. And then speed controller. The hold controller that I talked about is right here, specifically if you're using a hold control function. The gain X is going to be in folder 9, IPOS parameters, and then IPOS travel parameters. And then we can see the gain X right here. And these are the tuning parameters that you just saw in the startup menu. So if you're ever unsure of what these tuning parameters mean, then you can just select a parameter and then press the F1 key on your keyboard, and it will open up the help file for that parameter. And it will show you the setting range of the parameter, and the value in bold in the center would be the default value if the MOVIDRIVE was at its factory setting. So that's a good reference point to see where the default parameters lie, so that way you can understand what kind of range you should be in roughly for tuning your motor performance. The descriptions in the help file will vary depending on which parameter you click on, but it will offer some insight into how the parameter affects the tuning or other parameters that operate alongside of it. Whenever you are manually tuning, I recommend to always make very small adjustments to these parameters, either at the decimal place position or at the whole number position. So that way you don't introduce too extreme of values that can cause the motor behavior to be erratic and potentially dangerous. So we can close this. And if you see a parameter highlighted in black like this, then you can just press the escape key and it won't make a change. And the last thing I want to do is just back up these parameters to our offline projects. That way we have a good parameter set with good tuning parameters. So I'm just going to click on the MOVIDRIVE and then drag it from the bottom and drop it on the top. And it's going to ask, do I want to use the same name? And I'm fine with that. And I'm going to click on Finish. And now it's done. I can click OK. All right, that concludes Lab 8. In the next lab, we are going to introduce one of our application modules called Table Positioning. We'll go over what an application module is and then how it functions on the MOVIDRIVE. Then we'll demonstrate configuring, downloading, and operating the application module. So come back for Lab 9 to see how to do that. Thank you for your attention. Take care and have a good day.